Good morning, everyone. My name is Deirdre Denman, and I'm the marketing coordinator at EandM. Thank you for attending our webinar this morning titled Opportunities and Challenges Industrial 5G. During the webinar, you will be muted, but please type any questions or comments into the Q&A box, the chat box, or you can email us at webinars@eandm.com. I'd like to introduce your presenter for this morning, Jonathan Simpson with Siemens Industry, to get us started. Good morning, Jonathan.
Good morning. How's everyone doing? Hopefully you're doing fine. Welcome to EandM's Industrial 5G webinar. My name is Jonathan Simpson, and I'm the Siemens RuggedCom Product Marketing Manager and wireless subject matter expert for the United States. Now, in this online webinar, what we'll do is we'll explore the state of where 5G is today in the United States. We're talking about the United States only, and how this technology actually works, and how 5G technology is vastly different between carriers, and what will you need today and in the future in order to have 5G in your industrial or harsh environment. Okay, so we'll just get a kind of a foundation of what the CI group does. So within Siemens, of course, we have the Digital Industries Operating Company, and we specialize in leading industrial companies through the complexities of kind of the new industrial digital age. But within that operating company lies Process Automation Business Unit, and they specialize in advanced products, software, services, not only for discrete and factory automation, but also for a multitude of different industrial applications. And then within that business unit lies the Communications and Identification business segment. That's where I am. And this is where we focus on building industrial grade communications. That's key, industrial grade communication networks, and preparing customers for the new industrial age. So as you can see, the mission of the industrial communication identifications become the future-proof provider of industrial communications. So we can support things like artificial intelligence, Wi-Fi 6 blockchain, and of course, what we're talking about today, which is 5G. Right? So we build industrial strength, future-proof networks, and we serve every vertical from industrial sectors like automotive, chemical and food and beverage, or harsh environment verticals as well, such as electric power, transportation, which is ITS, defense, and water, wastewater. So Siemens, we have experience in building networks to support all of their needs. Now, in the U.S. region, 5G will eventually impact every vertical that Siemens serves. 5G will bolster industrial and harsh environment networks and enable IIoT applications that require large, low latency pipelines of data. And that's key. With latencies between or under between less than 5 milliseconds and less than 10 milliseconds, and it depends on the carrier, 5G will become the foundation of industrial networking no matter what vertical that we go into. So here's a small snapshot of the clients that use us to build their industrial networks. As you can see, we work with a number of different companies and a multitude of different applications as well. For example, we have one of our companies, they're using our current industrial Wi-Fi to power the AGVs inside their entertainment rides, and also on the distribution floor, right? We also have point-to-multipoint private wireless solutions that drive parade floats. So once you go to one of these entertainment venues, no one's actually driving the floats. It's all done remotely, and 5G will be a complement to that as well. So what we do is we see Siemens, we view 5G as a complementary technology, not taking over for these types of industrial verticals and these type of applications. However, before we get started to speak in depth about industrial networks, what we have to do is we have to lay the foundation that there's a stark difference between how data is used in enterprise networks or IT networks versus how data is used in operation technology or OT networks. This foundation will help us better understand where industrial wireless technology is today and where Siemens, where we see it in the future when it comes to enhanced industrial grade networks. So enterprise networks or IT networks are information based in that they receive information and produce responses, whereas most OT systems or factory floor systems have to be real time, meaning that the data must be captured and the action has to be taken usually between 1 and 4 milliseconds, or likely it's gone forever, right? There are many industrial systems that are considered mission critical. IT systems are not considered mission critical like plant floor. And they're mission critical in the sense that malfunctioning can bring about catastrophic consequences such as a loss of revenue, property, or even human life, especially if you're running safety systems on the industrial network. So our products and services are tailored for the wireless industrial environment, And it's going to be key in our 5G conversation. And we understand that industrial networks have specific requirements that differentiate it from like an enterprise network. So when designing an industrial wireless network, we can't make the assumption that all data is created equal, because it's not. And if you treat the OT network as a component or a subsystem of an IT system, it leads to networks that are fragmented, they're not easily connected or secured, and will ultimately impede on the full benefits of industrial IoT. So let's get into the cellular network. So cellular networks in the United States have evolved to a point where industry 4.0 and IoT applications are possible. Today with 4G LTE, industrial customers are able to conduct mobile service applications such as industrial controllers, security cameras, remote connectivity, and wireless backhaul. You can do that today on 4G LTE, right? However, as more users come online, what the carriers are seeing is that 4G LTE has just about reached its limit when it comes to capabilities. That means this basically means that 4G LTE is getting more congested by the year. So 5G will be able to handle 10 times more traffic, which is larger pipeline, and will be up to 10 times faster than 4G LTE. Now, although 5G will have enhanced features over 4G LTE, it does not replace 4G LTE, okay? So 5G's technology is actually built on top of the 4G LTE infrastructure. Right. Now, we have many applications that will benefit from 5G's enhanced technology. You have real-time remote access and ultra-low latency with 5G. So 5G would enable solutions such as real-time assisted work for maintenance. This is where you have a live feed for work out in the field, if you see the guy with the glasses on, for assisted work, and where he can have a camera with 5G connectivity on what he's working on and then have a live person in real time with extremely low latency. Latency is of under 5 seconds, giving him directions and getting feedback from that. Gigabit wireless backhaul is another one. Autonomous robots with real-time AI capability. We have autonomous robots today, but we need the bandwidth for real-time AI capability, and 5G will be able to do that. You have virtual reality and augmented reality. A lot of people don't know the difference. So virtual reality is a full digital representation of reality on a screen for you, whereas augmented reality is a combination of a real video feed with a virtual feed placed on top of it, and that is augmented reality. So with 5G, you'll be able to do both virtual reality and also augmented reality. You'll also be able to do robust real-time digital twin capability, human machine interfaces, flexible platform environments, and also you'll be able to do automated guided vehicles, which is AGVs, and automated mobile robots, which is AMRs. They'll also have increased functionality and industrial safety features today. With Wi-Fi and AC today with AGVs, once you get into video feeds is when you get a few problems with bandwidth. Right now, you can do all types of control and activities, but once you start adding that higher bandwidth with live video from multiple angles is when it gets kind of complicated and bandwidth suffers. And with 5G, you'll be able to do that. And also with IoT edge devices, you have the ability to have decision-making ability instead of processing in a central location, in a central location. So you have that IoT edge devices at the edge. So let's unpack a few of these of what 5G could actually offer. Just a few of these.
Hey, Jonathan.
Yes.
We had a question come in. Will 5G replace Wi-Fi?
No. So 5G will not replace Wi-Fi technology. Think of a stadium like a stadium is today. Within a stadium environment, you have what you call a distributed antenna system, a DAS system. When you go to a football game in a large stadium, and they have both a carrier system and a Wi-Fi system as well. So carrier system is when you bring in a phone or you have something that needs to be connected with a SIM card, you have that capability. But say you have someone and they just want to hook up to the Wi-Fi in the building, for personal use or business use, they'll have the Wi-Fi as well. So 5G does not take over Wi-Fi. Wi-Fi is also a technology that works in complement with 5G. Did that answer the question?
Yes, it did.
Okay. Yeah. Let me go back to this here. So with industrial 5G, factory environments will be able to run automated guided vehicles with real-time control, diagnostics, and video simultaneously. So although Siemens runs AGVs on, excuse me, our wireless networks today and our wireless technology, there are a few applications where 5G technology can make AGV applications more robust, and that's running simultaneous applications in real time with video feeds uh, in those applications. How does that actually work? So the AGV will reside on a private industrial 5G network, that's part of it, inside the factory, where the 5G wireless small cell will be strategically placed. And we'll get into small cells a little bit later. So subscriber units will take advantage of the robust millimeter wave technology. And then the millimeter waves of 5G, they differ greatly from the radio waves of 4G LTE. We'll get into that later. So what we're doing is we're doing a private network. It'll work pretty much like a Wi-Fi network today, but what instead of access points and clients, you'll have subscribers and base stations, right? And therefore, you'll implement this 5G wireless network. Will take considerable mapping and design, just like you would do a Wi-Fi network. So it's not like you can just put a Wi-Fi network in, and I mean a 5G network in, and it works. You do have to have mapping for that as well. So as I said before, you'll have this wireless subscriber would reside on each automated guided vehicle, and then you would that would have robust functionality and have seamless connectivity. And then like I said before, in order to have this type of functionality, it has to be designed as an OT wireless network, right? This can't be your regular IT type of network because you have a multitude of industrial applications, including safety in many regards, that will be running simultaneously on this automated guided vehicle. So that would be a subscriber unit on the vehicle, and it would talk to a base station within the building, a private network. So 5G could also power kind of distribution automation in the utility vertical. Distribution automation is a family of technologies that includes sensors and processors, information and communication networks and switches, and it had through which a utility can collect, automate, analyze, and optimize data to improve the operational efficiency of its distribution power system. So if you add 5G functionality to a DA application, this could make the entire ecosystem real time and fluid. And then 5G could power edge devices to supervise, measure, monitor, and control electrical loads on distribution systems and their substations. Right? In a DA solution, 5G can provide more robust information when it comes to asset optimization, automated internet equipment. I know with one 5G technology that Verizon Wireless is testing out today is that they have an automated drone that will fly over the power lines and give active live feeds and also spectrum analysis and kind of infrared and heat analysis on power lines today if there's an outage. So instead of driving the truck out, what they have is this automated drone fly up and fly over the power lines to find out where these deficiencies are. So you can do demand optimization, distribution optimization, system monitoring. You can do all of that through 5G as well. Another application would benefit from 5G is automated heavy equipment like shipping cranes. In this example, the shipping crane containers will be automatically loaded and unloaded using the robust bandwidth and low latency of 5G. Basically, you wouldn't have to have a person operating the crane. And then with real-time data exchanges, this process can become a totally unmanned process and increase the time it takes to offload goods while simultaneously, again, running safety, diagnostics, and optimization. And then here's the example of where the base station and also the subscriber unit would reside. So in this shipping crane example, industrial 5G, the wireless solution would also have to be designed by a professional like Siemens that understands this type of harsh environment. So you would have a carrier small cell, and then you have a subscriber unit there that would have to be strategically placed in order to benefit from the millimeter wave technology. And we're going to get into millimeter waves as well. All right. So here, here are some of the possibilities that we're seeing. You have the enhanced mobile broadband with industrial 5G. You get high data rates for data extensive applications in real time. You also get massive machine type communications. We'll get into that in a little greater detail. And of course, you have the ultra reliable, low latency communication. That's key with industrial applications. It has to be ultra reliable and have low latency. That's a must in industrial applications. All right, before I get started on the next section, do we have any other questions about what I just went over?
Nope. No questions.
Okay, perfect. All right, so what exactly is 5G? So many experts can't tell you exactly what 5G really is, and wireless carriers in the United States have different opinions and approaches as to what constitutes 5G functionality over 4G LTE. The governing body of 5G technology is a global initiative called 3GPP, and this stands for the Third Generation Partnership Project. This organization is made up of seven telecommunication standards organizations, and they're known as organizational partners. And basically, 3GPP set the standards for 3G, 4G, 4G LTE, and they set the standards for 5G as well. So 3GPP basically defined 5G as the next step towards increased functionality over 4G LTE as it meets efficiency limits, as 4G LTE meets efficiency limits, right? So you have um, these five different technologies that make up 5G, right? So 4G LTE, like I said, is very close to reaching efficiency limits, as I stated previously. Hence, it expected that LTE will remain as the baseline technology for wide area broadband coverage in the 5G era. 3GPP will continue working on enhancing 4G LTE. Let me say that again. So 3GPP, although they've launched in 5G, they'll continue to work on enhancing 4G LTE, not only from the radio perspective, but also from service delivery. So they're trying to make 4G LTE better while they're developing and launching out 5G as well, right? So interworking with 4G LTE will remain a critical factor for 5G. So there are five new technologies that provide the foundation of 5G. These are millimeter wave, small cells, massive MIMO, beamforming, and full duplex. So let's dive a little deeper into each one of these so you can better understand how this works, because this is key when it comes to a factory environment, right? So as 4G
Hey, John.
LTE, yes.
Another question came in. You may have mentioned it before, but will 5G replace 4G?
So no, so 4G LTE is the foundation technology for 5G. And as you'll see as we go over these next few slides, 4G LTE is considered the foundation and it's not going away. So it's not like 2G and 3G, because 3G is going away this year. The carrier is actually shutting down SIM cards and functionality with 3G. But with 4G, it's a baseline technology, and that's because 4G LTE was based off of fiber optic capability and fiber networks. So 5G is built on top of 4G LTE. So no, it does not replace, but it's built on top of 4G LTE. 5G is, right? So with 4G LTE, as we see more devices come online and they have slower speeds and drop connections, the solution is to open up new spectrum in the 26 gigahertz through 300 gigahertz millimeter wave range. This section of spectrum has never been used, so it has a lot of capabilities because it hasn't been used. And what it'll do is it'll help it increase speeds and offload traffic. However, there is a catch with millimeter waves. So millimeter waves do not travel very far, unlike 4G LTE. Okay, millimeter waves do not travel well through buildings as well. And millimeter waves tend to be absorbed by plants, trees, rain, and let's just say other water-based objects that get in its way. So research has proven that 95% of cellular 5G frequencies are up to 100 times worse at penetrating walls, glass, and buildings. So when you have a 5G signal out there, unlike 4G LTE, because it's in the millimeter wave range, it does get absorbed by rain, trees, people, shrubs and stuff like that, and it doesn't pass well through buildings like it does with like 4G LTE. All right. So today's wireless networks, they rely on this very high powered cell towers, and that cell tower, think of that as a 4G LTE cell tower, to broadcast their signals over long distances. But higher frequency millimeter waves have a harder time traveling through obstacles. So the carriers, what they're doing, what their solution is for this, is to make small cells. What exactly is a small cell? So you have your main one right there, and then you have these small cells to pop up, right? So since 5G millimeter waves travel shorter distances and have a harder time propagating through objects. A small cell network of base stations, they're needed to relay the information around and throughout buildings, as well as around objects. It's like we said, 5G millimeter waves are different than 4G LTE. As you can see in the middle of the screen, that's your 4G LTE tower, and you can get access to that. But if you want 5G, you're going to get it off these little small cells. Okay. So small cell networks solve the problem using thousands of these little low power line base stations. And these base stations will be much closer together than traditional towers, and they form a sort of relay team to transmit signals around obstacles and throughout buildings. Okay. So you have millimeter waves as the first technology, and then the second technology. In order to get the 5G and to propagate correctly over an area, you need these little small cells. Okay. And these small cells can take the form of all types of different devices, right? So wireless carrier small cell networks, they take on many forms. Some small cells are on the tops of street lights, on poles, intersections. Others on the form of church steeples, water towers, even fake trees. I'm sure you guys have seen fake trees. They also have fake trash cans that'll beam these down streets as well. So together, these small cells make up a network that can support the 5G network. In addition, 5G has what we call massive MIMO, or massive multiple in, multiple out, and that increases the number of ports that can be connected by hundreds. And this allows for millions of devices to be connected to a 5G network. To give an example, for a 4G LTE cell tower, that tower usually has 12 ports on top of it. This one, with the small cells and the way 5G, the technology works, you can have hundreds of ports, which means you can have millions of devices, which means if you're in a factory, you can connect millions, up to millions and millions of devices, just with the small cell network. And we'll get into that a little later as well. So you have millimeter waves, you have small cells, and the next technology is called beamforming, which is pretty neat. So today, your 4G LTE towers, what they do is they propagate signals in every direction at once. So when more 4G LTE devices are added, this increase can lead to interference, and that results in slow speeds and dropped calls. Well, 5G has beamforming technology, and this allows for a base station to send a focused stream of information to a specific user. So as you see on the screen, you have user A and user B and user C. As that user moves from cell tower, small cell to small cell, that beam of information is specific to that device. So this focused data stream prevents interference and it promotes efficient wireless connections. So beamforming also allows for more incoming and outgoing data streams at once. However, the technology is robust enough to only send relevant data to your device. So no matter where you go, in a city, or if you're in a factory or wherever you are, beamforming will always have that specific line of information coming towards you. Okay. So in addition to beamforming, 5G also has the capability of what we consider full duplex, right? Meaning that sending and receiving data can happen simultaneously. Now, right now, it's just kind of half duplex when you talk about 4G LTE. You can't tell because it happens so fast. But with 5G, you have the capability of full duplex to send and receive at the same time. And this greatly speeds up communications between devices, right? So we have all these future possibilities for the industrial space, right? So in summary, 5G can provide customers with options of handling 10 times more traffic, a bigger pipeline than 4G LTE. You have speeds up to 10 times faster than 4G LTE. You have these massive wireless sensor networks, closed loop control, and the ability to have applications such as augmented reality, human machine interfaces, virtual reality, and just a massive amount of data going to these devices, right? I was going to stop and see if there are any questions at this point over the possibilities of 5G.
I don't see any questions at the moment.
Okay, no problem. All right. So, what are the challenges with industrial 5G in the United States, right? So, there are many opportunities that have been associated with 5G's technology, and I'm sure you've heard it from me and other people and other companies out there. There are many challenges, but there are also many challenges that exist in the current 5G environment that prevent a true industrial 5G solution from coming to fruition. Some of these challenges are that speed, latency, and standards differ by carrier. And then wireless carrier 5G deployment will be in major and mid-major cities first. And even in those areas, 5G doesn't blanket the entire city or suburbs. For some wireless carrier networks, manufacturing devices certifications they need to be uh, certifications will need to gain access to acceptance into their networks as well. So, give an example. When a device comes online with Verizon, Verizon only allows certified devices on their network. So you just can't go buy a SIM card and plug it into anything because it won't work. It has to be certified. AT&T is the same way. And then for some wireless carriers, they have relationships with small cell providers and DAS. We'll get into DAS later, and they have their hardware tested and certified on their network as well. So you'll see like a Nokia and a Verizon try to work together, or Qualcomm and a AT&T and T and so forth, right? And then industrial customers interested in 5G have to reconsider both OPEX and CAPEX expenses when deploying 5G as well. Because just like your cell phone, you buy your phone, you can have the device, but you pay a monthly fee. Whereas with Wi-Fi, you're going to pay your wireless carrier, but you're going to have to pay a fee when it comes to 5G as well. So there is an OPEX and a CAPEX expense with 5G. All right.
Hey, Jonathan.
Yes.
How susceptible is 5G to interfere with Wi-Fi or 4G networks?
Wi-Fi is going to be on a different signal than your 5G. Like I said, for 5G, you're going to be in the gigahertz range. Wi-Fi is going to be in your 2.4 or your 5 gigahertz range. So those are not going to interfere with each other, and we'll get into that as well as far as spectrum. Um, so that won't have any crosstalk or any interference whatsoever when it comes to that. And it depends on how you design it as well, and which carrier you use. But in a sense, it does not interfere, not at all. You can run both in any environment. All right. So because there's not a bandwidth standard for 5G, each carrier has gone about their own way of pushing and keyword marketing their version of 5G. So, for instance, AT&T and Verizon Wireless have bought the following spectrum in the millimeter wave range, as you see on your screen. AT&T has about 300 channels in that 24 gigahertz to 28 gigahertz range, whereas Verizon has about 1,000 channels in the 28 gigahertz to 39 gigahertz range. So, as discussed earlier, millimeter wave ranges have a high data rate capability, but they need line of sight pretty much in order to see the full benefits of 5G at those speeds. So, in contrast, you probably have seen this on TV that T-Mobile has brought the 600 megahertz range for their 5G, and it's at the end of the spectrum. Uh, this range offers much greater distances than the millimeter wave range. The 600 megahertz range only has a slight speed increase over their 4G LTE. So, to give an example, and I'll have an example, I think, on the next screen. But T-Mobile, I think their 5G is rated at maybe 40 megabits a second. That's what they consider 5G, right? So, and we'll get into that, I think, in a few slides. So, in some cases, T-Mobile's 5G speeds are only 30% faster than their 4G LTE speeds, right? So, in addition, there's a general assumption that 5G data rates and speeds have consistency across carriers. But the truth is that the speeds differ greatly by carrier as well. So, for instance, AT&T has three different flavors of 5G. A lot of people don't know that. They have 5G E, which is 5G Evolution, 5G, and 5G Plus. So, 5G Evolution has an average of 40 megabits per second with peaks of 400 megabits per second, but it depends on the area and conditions within the area. All right. AT&T's 5G has the same average and peaks of 5G evolution. However, the carrier, AT&T states that it can achieve these speeds in under 10 milliseconds latency. And then AT&T has 5G Plus, and 5G Plus has an average of 400 megabits per second with peaks of 2 gigabits, and AT&T indicates that it can achieve these speeds with under 10 milliseconds latency as well. So if you have an AT&T phone and you're traveling around a city or somewhere and you look at it and you see 5G, you have 5GE, 5G, and 5G Plus, that means you're moving between these different data rates, right? So by contrast, Verizon has one flavor of 5G and has an average data rate of 1.5 gigabits per second with peaks of 2 gigabits per second. So faster than AT&T's. And Verizon states that these speeds can be achieved with under 5 milliseconds latency. So in contrast, like I was talking about T-Mobile, T-Mobile's 600 megahertz 5G has produced speeds between 35 and 40 megabits per second, but it averages around 34 megabits per second across the nation. So actually, Verizon and AT&T's 4G in some cases is faster than T-Mobile's 5G. So as you can see, 5G speeds across carriers vary greatly. And this happens to be taken, it has to be taken into consideration when considering these carriers for like a 5G application. So where does that lead us? So let's go back to 3GPP. So 3GPP has these different releases throughout the year, right? And they have these hardware and software releases that determines 5G's current and future functionality. The key word is future functionality. 5G is currently on what is considered Release 15, which is geared for enterprise use. All right. In October, September-October timeframe, Release 16 will be launched this year. In like I said, September-October, and Release 16 will power industrial IoT and have enhancements for ultra reliable and low latency communication. So right now, if you have another organization, company come up to you and say, we have this great 5G application, you can run 5G now. Release 16 has not come out for the United States, and it's going to happen, like I said, in September, October timeframe. And that Release 16 actually powers industrial IoT for ultra reliable, low latency communication. So until Release 16 is launched and tested, any 5G solutions will be for enterprise solutions and not for factory, industrial IoT or harsh environment IoT applications. Okay. So which one, as far as infrastructure? Let me stop. Let me stop for any questions. Any questions on 5G to this point?
One question that came in just now is 5G considered better than Wi-Fi 6?
No. So Wi-Fi 6 and 5G are very similar. Will be very similar. Wi-Fi 6 will have a little bit better latency and a longer range than 5G for what they're developing right now. So I wouldn't say 5G is going to be better than Wi-Fi 6. I think they're going to be complementary and they're going to have exactly the same kind of bandwidth and throughput. From what I've seen and what I've discussed with some of our product development guys that are developing our Wi-Fi 6, is that it will be, you know, pretty much on par with what 5G is touting. And in some cases, in the industrial environment, especially, you will have some greater application and maybe increased bandwidth because of the protocols that Siemens is going to put on top of that Wi-Fi 6. And you'll know, we can go over protocols later on in another webinar, a Matrix of Wireless webinar, where I talk about that. So from an industrial standpoint, they're on par with each other, but Wi-Fi 6 will have those the industrial protocols that help with redundancy and also other types of communications, IPCF, MC, and IPRP, as we call it in Siemens.
And also, will existing Scalance 4G ITE hardware be compatible with 5G?
The answer to that is no. So with 5G and Release 16, you need new chipsets. So what we're doing is we're developing new products based off of those chipsets. So it's not like it's going to be a software upgrade with Release 16 because Release 16, like I said, you need a hardware upgrade. So you won't be able to just automatically do a software and just upload, the Scalance, what is it, the Scalance M876-4, and then it becomes a -5 through upload. No, that's a chip change, and so that means new hardware. Also, for the carriers, that means new SIM cards. So any existing SIM card that you have today, once Release 16 hits, you can't get a 4G LTE capability or even 5G today, and then Release 16, you'll need a new SIM card, right? And I know that because Siemens sells SIM cards as well, and I'm over the SIM card business, so I do understand it from the carriers. All right. Okay. So currently, and I know this is busy, but I'll get through this really quickly though. Currently, there are two options for industrial 5G infrastructure. The first is a 5G, what they consider a multi-carrier active DAS, or what they call the distributed antenna system. And active DAS is a fiber cable rich environment that can handle basically multiple carriers at once. So think of this as where your football stadium comes into, or a baseball stadium. Those have active DAS in those stadiums where you can do a multitude of different type of connectivity options, right? You can this type of infrastructure is used for large venues and companies where you have many wireless devices, right? So a DAS system could be used to power all devices in a facility, and it's secure, and that production data does not leave the premises. So we have some very large venues and companies that use the active DAS. In case they want to use more than one carrier, we have some companies that want to do that. So it has the highest bandwidth and security and reliability, but you need carrier approval. An active DAS costs somewhere between $1 and $2 a square foot. So if you have 500 square foot, 500,000 square foot facility or a million square foot facility, this can be a little bit expensive, right? And companies that offer active DAS is like a Corning or a CommScope, right? So this means that the carrier has to approve the construction of the DAS infrastructure before they will agree to release the signal to the premises, right? And this is usually the case in the active DAS. What we're seeing more for the industrial environment is these small cell infrastructures for private networks, okay? So a small cell deployment, and we talked about small cells, this type of deployment is useful in industrial application in only that the manufacturing cells that need industrial 5G get the signal. So in this scenario, you have the end user, they can be more surgical and precise in the way the wireless signal is deployed in the environment. Because for instance, I mean, you really don't need 5G, that type of bandwidth and that type of ultra low reliable communication for the entire facility, right? So whether you have one manufacturing cell that needs 5G or five that need 5G, or say you have a couple AGVs, you have 60 or 70 AGVs in a distribution center that need 5G, you can deploy a small cell in that facility to a private network with small cells to make that happen, right? So, not every manufacturing cell may need 5G. So with small cells, you have this facility, you can tailor which manufacturing cells receive the signal. And by doing this, you develop this in that manner, you can develop the end user can make sure that the millimeter wave signal is directed to the right manufacturing cell or AGV or mobile robot or whatever. You don't have, but you have to get a company like Siemens in and professional services to design it, just like you would do a Wi-Fi signal. It's no different. Okay. So understanding how 5G propagates is what I was trying to do earlier. And with Siemens history within industrial environment, you need to understand how that works. In Siemens' view, we view that private small cell networks is the option best for industrial 5G, and we are developing a industrial 5G private network, uh, and we will do that as soon as we're in development now, but we're waiting on release 16 in order to start doing the testing, right? So we believe that a private industrial 5G network provides your maximum data privacy and security, and that it can support ultra reliable and low latency communication. And this is critical in industrial environment because, like I said, IT data used in the IT environment is totally different than the OT environment. So we're waiting for that release 16, to get that extra capability. So a private network would also be dedicated for industrial use and not have any other IT related traffic on it that can slow connections and increase latency. So we don't want to increase latency in a private network, right? So
Hey,
Siemens,
Jonathan.
yes.
Um, in reference to your previous slide, the question is, why would I use 5G over Wi-Fi?
It is a choice. So with Wi-Fi 6 that's coming out as well, it's up to the company to see where the benefits lie. The carriers have not really been in the industrial space. And I'll just be frank and honest. With the carriers, what they're seeing from their customers is that everyone has a cell phone or two or three in a household. So the only way that they're getting business is that, one carrier runs a promotion and everybody runs to Sprint. Somebody else runs a promotion, everybody runs to AT&T. So not seeing growth that way. So they see growth in the industrial space. So that's why you see the push of 5G in the industrial space is because the carriers, quite honestly, and quite frankly, see it as a better revenue opportunity for them being in get into that space that they haven't been in. So it's up to the person to or the company to see and make the distinction of, okay, if I want 5G, I'm going to have this type of ultra low latency and this type of communication. But you can get the same thing with Wi-Fi 6 when that comes out as well. So it's actually one's not better than the other one. It's up to the company to see what's more beneficial. Do I deploy a Wi-Fi private network or do I deploy a 5G private network? It's up to the customer. So, like I said, Siemens, we understand that a few things need to happen before you actually have true industrial 5G that can benefit industrial and harsh environment customers. And first, like I said, 3GPP has to launch release 16, and after release 16, there's a release 17 as well. And so that they can fully, so that 5G can fully support industrial applications. Um, Second, with the launch of release 16, that doesn't mean you're just going to have this influx of industrial 5G devices. So you need to fully understand that industrial 5G hardware and software, what the capability and availability is. Like I say, the carriers, you have to go through testing. So it's not like you're going to hit release 16 and then they have all these devices. They have to go through testing as well, right? Third, Siemens, we consider 5G a complementary technology that'll work in conjunction with a Wi-Fi 6 and other wireless technologies. Therefore, one has to closely consider what industrial 5G means to your business and what applications you're going to have. What applications you will have to benefit your business. Like what application is going to benefit your business? Because what you don't want to do is like, okay, I'm going to have industrial 5G. Let's go ahead and spend all this money and have all these base stations of subscriber units out there, and then you're using the same technology and the same data speeds and bandwidth that you've used the past 5 or 6 years. It doesn't make sense to do that. But if you do want to future-proof, 5G could be a fit for you, as well as, like I said, Wi-Fi 6 as well. Currently, Siemens is testing new private 5G industrial networks to take advantage of all these industrial bells and whistles for release 16 and release 17. So when it comes to the map, Siemens will have some remote connectivity, like the Scalence M876-4. That is our 4G LTE. There will be a 5 version of that, a 5G version of that, that will hit, I'm going to say, next year early for remote connectivity, and that will be AT&T and Verizon capable. I can't show this on the screen. I just got to talk about it, so I can't show you a roadmap, but I can talk about it now. And also, so that'll be our Scalence and also our Ruggedcom products. And then after that is, during that time, we'll be testing the private network as well for a couple companies when it comes to a 5G private network. So next year, you'll see kind of devices for remote connectivity for 5G. Then after that, you'll see in factory. But in concert with that, Siemens is also working on a Wi-Fi 6 devices as well. Okay. So that's all I have today. But please, any questions about what I just went over or anything about wireless in general, you can open the floor up.
Thank you. Yeah, we'll open it up for a couple more questions. If you have questions, please type them in the chat box or Q&A box, or you can email us at webinars@eandm.com. Jonathan, another question that came in is, so if we want to use 5G even on a private network, we will have to pay a carrier no matter what?
Yes, that is true. So it's not like a Wi-Fi network where you buy the Wi-Fi devices and you're on the 2.4 or the 5 the 5 hertz range. So with the carriers, just like they do with DAS networks, you have to pay them a monthly, or it'll be a prepaid. And from what I've seen with one carrier, I can't name them, but with one carrier, every device that's connected will have a base station, and then you have a subscriber. So think of the base station as your access point, and the subscriber as your client. Every subscriber/client will have to have a SIM or eSIM associated with it, which means that there will be a monthly, quarterly, or yearly cost with each device connected. And that's how they want to get paid, pretty much. Otherwise, you're just running Wi-Fi, right? You have a access point subscriber, and then you pay for that, and then you blast it out to the different clients. But with this, because it's on the 28 gigahertz, those ranges, each one of those, like say if you run an automated guided vehicle, each one of those is going to have a subscriber unit on it, which is going to have an eSIM or a SIM card connectivity with it. And with that comes the pricing. I know that Verizon, what they're doing today uh, is that they're going with a private network, and you have to pay for every subscriber that's on that base station. So say you have one base station, you have that eSIM in the base station, and then it relays that gigahertz range to all the subscribers, and you have to pay for each one of those as well.
So following up on that question, so Siemens is only providing hardware that will be considered 5G subscribers?
Yeah, so we'll be doing both the base station and the subscriber. You know, think of it as a Wi-Fi, like an access point in the client. We'll have a base station and a subscriber. Today, we actually offer SIM card connectivity. Actually, I developed SIM card connectivity for Siemens here in the United States. So I can see us offering a SIM card connectivity for 5G as well. I'm actually already in conversations with AT&T and Verizon about our SIM card connectivity to go with our base station stuff and subscribers.
Another question is, if the 5G is on the 4G LTE infrastructure for long distance, won't that limit the efficiency of 5G for remote environments?
No. So when it comes to an industrial environment, it has to be a fiber-rich environment. What you won't see in the United States is a cell tower talking to a factory. That's not how it works, and that's how the carriers, they didn't design their system like that. So you'll have to have fiber optic cable to run to the facility. And then once you have that fiber optic cable run to the facility, then you'll be able to have your 5G small cell infrastructure there. So think of, let me put it this way. So with 4G LTE, both Verizon and AT&T spent billions. I know Verizon spent almost $12 billion buying up all the fiber optic cable for the past 7 years. So what they did was they ran fiber optic cable to every cell tower so they could push this 5G technology later on. The same thing is going to happen with small cell networks. You will have to have fiber optic cable go to your facility, your manufacturing facility, and then within that facility you can run the small cell network. So it will be fiber optic cable. It will not be kind of a cell tower in a factory, like with a Wilson booster. It's not going to work like that. It will be um, with fiber. And with fiber, you can go as fast as you want. I mean, when you're communicating from United States overseas and watching YouTube videos, all that stuff hits the ocean floor through fiber optic cable. So, your fiber optic cable can take care of all of that without any latency or anything else, right? So it's not like 4G is going to slow down 5G. 5G is built on top of that system, and it uses more of the fiber optic network to make those faster speeds happen.
Another question that came in, is the concept similar to Wi-Fi Max, but with a cellular technology?
No, the concept is more with millimeter wave, with Wi-Fi Max, or with kind of a point to multi-point, that goes for miles and miles. With 5G, with the millimeter wave, you can go maybe up to 1,000 feet, but if you have, like I said, obstacles in the way, or there are people in buildings and trees or rain or something like that, or fog, it doesn't go as far. So it's not like a Wi-Fi Max. Siemens, we have a RuggedCom product called RuggedCom Win, which is kind of a Wi-Fi, a WiMAX type of product, and that's for long distances. But you don't get the data rates that you would with the millimeter wave. With millimeter wave, you can get gigabits and gigabits of data. With a WiMAX, or that, you can get maybe 100 gigabits. 100 megabits or 40 megabits, depending on device and how far away it is. So those are two different types of technology. So it's not like a Wi-Fi or like a WiMAX or anything like that. It's more of a something for greater bandwidth at a shorter distance.
Okay, and then the last question, do you have any comments on the rumors or theories that 5G is dangerous to humans?
I wouldn't say 5G is dangerous to humans. I've actually, in previous life, was a product manager for cell tower deployment. So I've actually been on top of one of those 300-foot towers. You don't want to get next to one of those. but you'll be far away enough from the small cell. So it's not like it's dangerous or anything to humans at this point. The studies show that it's not. Uh, but for right now, I would say that I wouldn't say it's dangerous, but when it comes to some of those large cells that are on those big towers, they're up in the sky for a reason. And that's because they blast a very powerful signal. Because 5G is smaller, millimeter wave, and it goes a shorter distance, they don't blast it as hard because they get absorbed. But right now, studies don't show that it's dangerous. I guess we'll see in a few years, though, right?
Okay, so that concludes our Q&A portion of the webinar. Thank you, Jonathan, and everyone who attended today. If you would like to review any portion of the webinar, a recording will be available on our YouTube channel and on our website at eandm.com. We hope to have you again for one of our future webinars, and thank you for joining us.
All right, thanks, everyone.